So cycle time is an important number, so we've got our map on the wall, and we go through and we write cycle times down on each one of those tasks. We sum it up, and that's the cycle time for that process. Now what it doesn't have in there sometimes is the sleeping time between the process steps. But that's cycle time, the total time, value added and the non-value added all together that it takes to execute the task. The next thing is takt time. And takt time is the rate at which the customer wants it, right? So simple formula, available time divided by customer demand. And what you do is you compare those two numbers together, right? So this takt time creates, takt is it's German for, I think it's for beat or rhythm of the symphony, or anyway, it's the beat at which we need to produce to, right? To meet customer demand. Because we've got 5 minutes to do 50 signatures, right? So we can do that math real quick. Let's think about what we really do. How many software changes do we need to execute in a year?
Depends on the project.
Add them all up, right? All the software changes on whatever the product is that we work on. Is that what you mean?
Yeah, no. It depends on
integration testing. You go so far, code freeze.
Okay.
Go back test. Fix with that. Continue. Go beyond that. Code freeze.
Okay, so if you take a look at a year,
it's ebb and when you talk about flow, it's an ebb and flow,
right?
Kind of back and forth. Is
testing and evaluation.
User journey. I mean, all you get.
Right. So if you take a look over some amount of time, if you've got some historical reference, it talks about how many changes do we make per year, and then we divide that by, take an average I guess, and divide that by 250 days in a year. We work 5 days a week, 8 hours a day, 5 days a week, top of schedule. All right, so we can calculate that time available for a 5-day a week schedule is 250 days. Customer demand, let's just pull one out of the air, right, is 500 changes. Right, so that means we got to execute 2 per day. Or maybe there's 10 changes, so we got to execute about 1 over a little more than a month. But it just sets the beat at which we start to look at one-piece flow and level load and those type of things. And then we compare them. If the cycle time is smaller than takt time, hey, it's all good. We're able to meet demand, no problem. Usually that's not the case. So here's an example. Here's our 5-day work week. Customer requires 357 contract actions per year. So we do the math. The takt time comes out to 0.7 days per transaction. That means that every 0.7 days, there's one coming out. Right? What is that, about every 6 hours? Right? So on day 1, you've got a couple coming out. On day 2, you've got 2 coming out, right? So it's, no, you don't have 2 coming out. It's 0.7 days per transaction. So multiply that times 8 hours in a day, and that tells you how many needs to come out. Or you can take a look at how many is that per week. But it just sets the pace that we need to produce at. Little's Law, this is talking about how fast can we respond to changes. So if we've got 75 requests in process and we can get out 15 per day, then what this says is it takes us 5 days to respond to changes in the process. Now this is a snapshot in time. Some days are a little faster, some days are a little slower, but we get out about 15 per day. So how fast can we respond? So if they said, and I use the blue paper, yellow paper example a lot, although we don't do anything on blue or yellow paper. But if they said, yeah, we want this to start coming in on pink paper now, right? Without doing a lot of expediting, how long would it take for us to get through that change? Well, if this was a process and everything that's in WIP is coming out on yellow paper, it's going to be 5 days until they start seeing pink paper contracts. Does that matter? Maybe they're okay with that. Maybe they're not. How much rework we have to do, expedited rework, to go redo everything. So, process lead time, some more math. So, to decrease the process lead time, we've got a couple of options. Let me back up. So, this process lead time is this WIP divided by exit rate. So, if we want to make an impact to that, you got to do two things. Decrease the work in process, increase the exit rate. Things that you do will make an impact to both, usually. If it's if there's a steady stream of work coming in, if it doesn't come in bubbles, then you make an effect. Changes that you make will affect both. And again, how fast can we respond to these changes? So when we calculate process cycle efficiency, again, these are measure phase type tools to see are we making good change. So process cycle efficiency determines part of the process that's value added. So we've got our value added time. So remember our map on the wall, right? It's got the yellow sticky notes and cycle times written on it. We add up all the ones that's got a green dot on it. And then we divide that by the process lead time. Exit rate, WIP divided by exit rate, right? And we calculate process cycle efficiency. You know, in the production world where they're making stuff, they're building helicopters or M16s or Toyotas. Well, I wouldn't say Toyotas. General Motor or government motors, right? That process cycle efficiency is about 5% or less, and that's typical in the American mass production type of environment that we're in. That is typical. In our transactional model, that's the information flow that we work in, guess what? We're just like it. We have about a 5% or less process cycle efficiency. Now, does that mean that, that Jerry's a screw-up? No, because again, it's not based on who's doing the work. It's based on what is the work that's going on. Yeah, so these formulas, these silly formulas that we're going through, we're not expecting you to go execute these and go do all that work. That's really what we make the green belts go do. You know, because they should know. That's what they do. But this helps to give you an understanding of what is it that we're really looking at. Why are we pestering you all the time about how long it takes for you to do some task? So we use that, and it helps create that baseline. So we don't get to manage by the gut. We got to use some metrics sometimes. What's going on? How do we create this winnable game, right? Because we don't want to see that document come back with questions or rewrites. We want it to go away. We did the work, go, right? Flow on down the line. Well, that means we got to do it right. And we got to do it on time. And we got to be complete. Well, that's all three. Yeah? Cheaper, faster, better, right?